Hello and welcome to this Jumpstart session. My name is Markus Fath and I will be talking about intelligent data applications with SAP HANA Cloud. So here's what we're going to do in the next 20 minutes or so. I'll show you a set of slides to kind of set the context and introduce specifically the multimodal capabilities of SAP HANA Cloud. And then we'll be looking at a GitHub repository where we prepared a bunch of exercises for you to run through. So basically, we are talking about SAP HANA Cloud, which is the backbone of our analytical and transactional applications and also many custom applications. And specifically, there are a set of so-called multimodal capabilities in SAP HANA Cloud, which comprise the spatial engine that lets you deal with georeference data. There is a graph engine that lets you analyze and query network data. And in addition, there's a so-called document store, which allows you to store data in JSON formats of documents. And last but not least, there is the machine learning library with a set of built-in algorithms that we're also going to show and use during the exercises. A little bit into the details. Let's start off with the spatial engine of SAP HANA Cloud. So the spatial engine allows you to store so-called vector data. So things like points and lines and polygons representing cities and rivers or admin boundaries. These georeference data that is embedded in a two-dimensional surface, so the surface of the Earth, and it is also connected to a so-called spatial reference system, which kind of depicts the model of the Earth, how you think about it in a flat way or in a round Earth way. There is a large number of spatial functions and predicates that allows you to manipulate spatial data, or also to detect relationships to two polygons, for example, intersect, and things of that nature. Last but not least, if you're looking at the consumption ecosystem, the GIS, the Geographical Information System community out there is pretty large, and there are a set of tools, and there is integration of SAP HANA Cloud and its spatial functions into these tools like Esri ArcGIS or GeoTools GeoServer. Next, there is the SAP HANA Cloud Graph Engine, which allows you to expose your relational data as a property graph, essentially as a set of vertices and edges which make up your network. And basically then we support two kinds of workloads. One is declarative queries for pattern matching. So if you're looking for a pattern like a person connected to another person living in France, so these type of patterns can be searched in your graph. And in addition, there is a set of built-in algorithms that we support with the Graph Engine, for example, to find shortest path or do community detection. These built-in algorithms, they are an integral part of our GraphScript programming language for the Graph Engine. The JSON document store, as the name suggests, allows you to store and query data in format of JSON. So whenever you deal with schema-less or hierarchical or semi-structured data in form of JSON, the document store is a good choice for you to take a look at. The interesting thing in SAP HANA Cloud is the JSON document store and the relational engine, so think of column tables and things of that nature, they are very well integrated. They live in the same transactional domain, so you can run joins between your JSON document store and the relational engine. Last but not least, there is a vast variety of statistical and machine learning algorithms well integrated in SAP HANA Cloud. That goes by mainly two packages, the PAL, the Predictive Analysis Library, and the APL, the Automated Predictive Library. So these functions and algorithms can be invoked directly via SQL, or if you're a data scientist mainly living in Python, there is a HANA ML client that allows you to tap into these algorithms and use them from your well-known Python environment, like from Jupyter Notebooks. Okay, with that, let's switch over to the GitHub repository that we prepared for you. And you'll find the link to that GitHub repository in the additional resources section of this session, or you simply Google for DA285v for virtual. So, of course, you are welcome to run the exercises on your own, and for that you would usually start with cloning or downloading the content of that GitHub repository. But of course, it also makes sense if you don't want to run the exercises on your own, you can just read through the descriptions that we prepared for you and maybe learn something new. The requirements to run these exercises on your own are as follows. So you need, of course, an SAP HANA Cloud system. The easiest way to get one is to subscribe for the HANA Cloud free tier or trial version. But important to notice, if you're just running on the trial version, you are only able to complete exercises 2 and 3. Exercises 1 and 4 are about the JSON document store and the machine learning capabilities, and these functions are not available in a HANA Cloud trial system. So you need a full HANA Cloud system to run that. Basically, to execute or run the exercises, you need a database explorer, which of course comes with the SAP HANA Cloud system. Our content is basically divided in 4 exercises. So first of all, we'll deal with JSON data and have a small Jupyter notebook where we ingest data from OpenStreetMap. Exercise 2 is about handling spatial or georeference data. And exercise 3, we talk about the graph engine, how to analyze networks. In this case, we are mainly running community detection algorithm on a street network. And last but not least, we are utilizing the machine learning capabilities and run a simple k-means clustering algorithm on our data to find land use classes. First of all, let's look at the getting started section. The base demo scenario that we had in mind when creating these exercises was a scenario that we showcased during this year's Sapphire, and it was about finding new sites, suitable sites for placing new electric vehicle charging station. I encourage you to follow the link to see a demo video, but basically what you see here in this picture is the yellow dots depict existing EV charging stations in the Orlando area. And the blue hexagon cells depict areas within Orlando which are suitable for placing charging stations, but where are not yet charging stations being built. So these blue areas indicate potential new suitable sites for charging stations. And the way this works in the demo is that we're looking at location characteristics where currently charging stations are being set up. And then we find other areas within Orlando which also have these location characteristics, but where no charging stations are built. To run the exercise scripts, you mainly need the database explorer. So this gives you a SQL console, and also be advised that in the data folder there are exports of HANA tables, which you can simply import and run the exercises on. There's a description, especially how to import the data using the database explorer. Also in the Getting Started section, you find information how to set up your HANA Cloud free tier or trial system. And if you have a full HANA Cloud available for you, I also inserted some links on how to enable the so-called script server in order to do the machine learning exercise, and also to enable the doc store to run the first exercise. There's also additional information how to set up, for example, dbeaver, which is an open source SQL editor and database administration client. QGIS is a spatial client, which gives you the possibility to plot spatial data on a map. It's highly recommended. QGIS is a nice tool to work with. But let's see what content is actually in the exercises. Again, exercise number 1. If you just have a HANA Cloud trial system, you can't run it on your own because HANA Cloud trial don't provide the JSON document store out of the box. But still, you may want to read out the exercises. We connect to OpenStreetMap in order to get some street network data. Basically, what we are doing is we're using Python to connect to Overpass, which is an API that lets you suck out OSM street data. This is a query to this Open Overpass API where we extract ways, essentially streets and street junctions. And then we are using HANA-ML, the Python client, in order to put that data that we retrieve from OSM into a so-called JSON document store collection. And finally, we are inspecting the data a little bit, discussing how it looks like, streets and street junctions. We are flattening out the table by using the unnest function, which is part of the JSON document store. And finally bring a little bit of that geometry onto a map and end up with creating a table that contains now our street network vertices and edges, which are the junctions and street segments. In the second example, you may start with essentially importing some data from the data folder. Essentially, we're looking at charging stations and building structures. These charging stations are essentially from the whole US, and the building structures are from that Orlando area. We import the data and then play a little bit around with it. So we analyze the charging stations point data, looking at certain distributions of these charging stations, creating a map where we plot these charging stations. We run a little bit of hexagon clustering in order to understand the spatial distribution of the charging stations. And then we'll run through a couple of basic spatial functions and predicate on the building structures. So this is a building structure. It's the footprint of a house depicted here. We'll walk a little bit through certain format conversions and stuff like that. And finally, for example, calculate the buffer and the centroid, which is depicted here. So a house footprint with its centroid and a 20-meter buffer around that. Finally, we're deriving spatial features from the building structures. Essentially, what we're doing is we're tessellating our area with hexagon grid cells, and then we are calculating or summing up the building footprint area by these hexagon cells. So we are creating spatial features that describe the area of the hexagon cells, and this is the prerequisite where we'll later do on land use classification by looking at the distribution of certain building structure classes, so be it residential homes or commercial buildings, looking at this distribution and derive clusters from these. Okay, that basically concludes the second exercise. To start with exercise number 3, if you haven't ingested the OSM data via exercise 1, you'll also start here importing data via Database Explorer, so the street network. If you ran through exercise number 1, you already have that data in your system. So one thing that we are doing is that we simplify the network. And here's the idea. Basically, the network consists of road junctions and road segments. And as it happens, the OSM street network data is a little bit, let's say, redundant, because certain nodes in this network are just introduced to kind of bend the street around the curve. But they are not really crucial to analyze the topology of the street network. So one thing that we'll be doing here is we simplify the network. So here our network is depicted, and what we are doing is we remove all the irrelevant points, which are the red ones, and just keep the green points in our, or vertices in our network. The green vertices are the vertices that actually are relevant in terms of there is a junction, there is a split of streets and things like that. The simplification massively reduces the complexity of our street network and also then reduces the amount of data that we'll be looking at. One example that we're doing on that street network is that we run community detection. So this is the kind of final result. What you see here is the street network, and the colored areas are distinct communities. They are a partition of our street network that optimizes modularity. So these communities are very well connected in between, but not between the communities. So that's what this so-called Louvain community detection algorithm does. This is very helpful information. For example, also if you're in the utility space and you're looking for optimal routes, how your waste truck collects waste, then you might be starting at your community, at your city, by looking at these community partitions, because there are or a lot of streets in between, there are a lot of connections in between a community, but less so between communities. So we'll guide you through that, how you run graph script algorithm in order to come up with these communities, and then over to exercise number 4, which again then builds on these spatial features that we created looking at the building structures and the building structure classes, where we essentially derived spatial features for each hexagon cell. So in this case, for example, for one specific hexagon cells, we found 3 different building classes, and we're looking at the area for each building class. So for example, educational buildings in that grid cell sum up to over 1,000 square meters, and we're looking at the distribution of these building class areas for each grid cell. The distribution is kind of exposed to the HANA machine learning capabilities, essentially to a very basic, very simple algorithm which runs k-means clustering. So I'll guide you through how to set up and prepare the configuration for you in order to run a PAL unified clustering algorithm, where we simply run k-means clustering on our data, which results in a set of clusters, which we then describe and depict their centroids, essentially, which we finally then plot on a map. So what you see here are the land use clusters. So the blue ones are primarily residential houses there, and here the brown gray ones are commercial areas, mainly commercial areas. And one thing that we're doing here is that we finally then overlay the locations of these charging stations to these land use clusters in order to understand that primarily existing charging stations are located in commercial areas, which of course makes a lot of sense. And finally, if we want to go back very quickly to that scenario, what I've shown you through the exercises is basically some of the most important building steps in order to come up with these site suitability application. So of course, having land use clusters is just one piece of what you want to consider in order to evaluate site suitability for charging stations. You may very well also look into, for example, points of interest, so the locations of restaurants and cinemas and things of that nature, but also looking at the street network, so where are highways, where are certain kind of speed limits that are there for certain streets, and you may want to incorporate all that information in order to come up with a prediction model to predict the suitability of certain areas to build up charging stations. Okay. That brings me to the end of this piece, and we'll switch over to the question and answer session.
Live Q&A.
Okay, there is one question related to the JSON document store. Mainly is about the purpose of the JSON. Now that question is gone, I'm sorry. But basically, to give you a brief answer, why should you use the JSON document store? I mean, whenever you, as in an application, handle JSON anyway, of course, it's a very simple way to just dump that JSON document store without needing to figure out how to map it to a relational schema. So that might be one reason. If you're dealing with hierarchical and nested data structure, JSON is the way to go. And it's an easy way to handle these kind of schema-free or schemaless data. Again, keep in mind that you always have the ability to relate your JSON data in the document store to your relational data in tables, because you can run joins in between. Okay, the second question is also gone. That's very nice. Some folks have the question that are the multimodal capabilities that are just presented, are these an integral part of SAP HANA Cloud? And the answer is yes. So the JSON document store, the spatial engine, the graph engine, and the machine learning capabilities are integral parts of SAP HANA Cloud. However, what you need to do in order to enable the doc store and also the script server is you need to adapt the configuration of your HANA Cloud system and enable the script server and the document server. And this requires at least 3 virtual CPUs, which you don't have in case you're just running SAP HANA Cloud Trial. Then there is another question, can I use JSON store in DataSphere? Technically, yes. The database underneath DataSphere is, of course, a HANA Cloud system, and technically the JSON document store would be there. However, as you are accessing and maintaining and manipulating your data through the DataSphere application, there is no straightforward way as of now to kind of deal with JSON data from a DataSphere perspective. But let's say this is a current limitation which will for sure be gone in the future. If you currently have JSON data in a separate HANA Cloud system, one way to expose it to DataSphere is that you would create a SQL, that means a relational view on top of your JSON data, and then refer to that JSON view from DataSphere and essentially allow DataSphere, for example, to access the data via that view or to replicate the data into the DataSphere environment. Okay, that brings us to the end of that session. I hope you will enjoy the exercises. I encourage you really to set up a HANA Cloud trial system and run through the exercises on your own. There is interesting concepts in there which might spur additional ideas. I wish you a great day and rest of the TechEd. Bye-bye.